Hello and welcome to Day in the Life of the Hudson and Harbor. We're in the lower estuary section of the estuary, and we have a lot of partners today that are going to help us with doing our sampling. We're moving from Yonkers all the way up to Newburgh Bay, so a really nice reach. And we have the influence of the Atlantic Ocean, bringing us a little salt along with the tides and the freshwater section in this area. So lots of fun things. What I'm going to tell you is that you would want to get your recording sheets out. You're going to want to have a pencil and a piece of paper if you don't have that recording sheet, because you're going to follow along and you're going to be collecting data with us as our partners share some of that with you. In this part of the estuary, we want you to pay special attention to a couple of things. The fish that we're pulling in our nets and turbidity. And if you don't know what turbidity is now, you will soon. And remember, there are 2 other videos just like this that will be available to you. One looking at the harbor and one looking at the freshwater section. So you have a chance to really look at things much more broadly. Okay, let's go.
Hey, it's Miss Susan. The next water quality parameter we're going to check is that of turbidity. If you haven't been introduced to turbidity, turbidity refers to all the suspended particles in a natural body of water that can make it appear a little murky or even discolored. This is a sample from the river with turbidity. Now, can you think of some of the things that might be drifting around in the water that would make it appear like this, either naturally occurring or related to human activity? That's right! Some of this, why the water looks muddy, is it might just be mud, suspended sediments, little clay particles drifting around in a flowing water body, of course. To me, the water sometimes almost looks a little green or olive colored. Some of that turbidity could be algae or microscopic plankton drifting around in the body of water. You expect those things in an estuary. How we measure turbidity has to do with how far can you see through the water as a result of all that murk that's drifting around in there. And a really low-tech device we can use is called a turbidity tube. At the very bottom of that long tube is a little black and white checkerboard disc that looks like this. This is called a Secchi disc, named after the guy who invented it. And why we use this is because even when this is submerged in a murky body of water, this black and white pattern right next to each other is very high contrast. It's easy for the human eye to pick this out in a murky environment. So how the tube works is we're going to fill this at least part way with our estuary water sample, and I'm going to try to look down through the top, through the entire length of turbid sample, and see if I can pick out that pattern on the disc. If I cannot, I'm going to have my partner, Miss Bruins, start to drain the sample out the bottom of the hose while I keep looking until enough water and murk has drained out that I can just barely begin to pick out that black and white pattern. At that moment, I'll ask my partner to stop, and we're gonna agree, we're gonna both check it. If that pattern is just barely visible, our turbidity reading will be how many centimeters of water were left that we could finally see through to our target. When I look through the entire length of the tube, trying to find that black and white Secchi disc, I got nothing. So my partner, Mrs. Bruins, is going to start draining that hose while I keep watching, trying to wait for that Secchi disc to appear. Stop. How about now?
Yes, just about.
Okay, just barely. And it's good to always have more than one scientist do a test. So if she and I agree that we can just barely see through that murk to that black and white disc, our turbidity reading is going to be how many centimeters of water we can properly see through to that target. So we'll put a dark background on this to make it easier. And so here's 40, down here's 30, there's the 35 mark. So if I hold this nice and level, how many centimeters of water?
This is Ellie Cariff reporting from the Center for the Urban River at BZAC from Sarah Lawrence College in downtown Yonkers, River Mile 18, and our sample site is this sandy beach behind me over here. And some of the sampling we're also doing is in this restored tidal marsh and tide pool to my left. All right, so you can see this fish here has only one dorsal fin, a forked caudal fin or tail, and it's silvery at the bottom and totally iridescent at the top with like a sort of fun rainbowy layer in the middle, its lateral line. So you could take a minute to identify this fish.
We are here at the scenic Matheson Park in the village of Irvington. Our mileage is River Mile 25 East, directly west of us. And you can always look, it's just starting to happen now. You would see Piermont Pier. We are going to be seining in a few minutes, and just to describe the surroundings, Matheson Park has a relatively small but really accessible area for seining. It's a sandy beach, and in a few minutes we should have hopefully a lot of success collecting some river species. Take a look at this fish. Pay special attention to the markings on the side of this beautiful fish. If you identified the fish as a striped bass, you are correct.
Hey everybody, welcome to Piermont Pier. This is our local sampling site. This is an amazing spot to sample. We have this pier that extends 1 mile out into the middle of the Hudson River. On the northern side where we typically sample, we have a sandy beach bottom with a riprap lining going all the way down the pier. Now, we are just north of the Piermont Marsh over here, so we definitely have some marsh influence, as you can see behind me. And because we are on this sheltered cove kind of environment due to the pier, that is definitely going to influence what we catch today.
So we're going to look at salinity right now. Salinity tells us about a relationship to the Atlantic Ocean, which is to the south of our site. We're interested in what's that influence of the saltwater in this part of the river. If we were in the Atlantic right now, we'd be looking at 35 parts per thousand, which is how we measure this in parts per thousand. We are using this very cool tool called a hydrometer that works on density. So saltwater is denser, heavier than fresh water, and there's a little plastic arm in this tool that's floating just on the top of where the saltwater beats the fresh water. So if you zoom in and use your eyes carefully, what do you think that hydrometer says? And you're going to look at the number that's right on the bottom. What do you think? If you came up with 11 parts per thousand, I think we'd be in agreement. And you're going to record that now on your data sheet.
Hi everyone, I'm Ashley Curtis. I'm here with the Outdoor Science Alliance, and I'm here at Nyack Memorial Park in Nyack, New York, as part of Day in the Life of the River. And Nyack is at about River Mile 28.
So as some of you might be finding, when you're doing your Clearwater identification guide, you sometimes identify a striped bass as a white perch. And so we have the striped bass and the white perch side by side here to point out some of the key differences. Right now we're looking at the striped bass. You can see that it has those long lines from its head down to its back fin, has these two dorsal fins at the top, and they are separated. Now if we look over here at our white perch, we notice it has more of a hump, right, in its middle, and it doesn't have all of those lines going down the side of its body. It actually just has kind of that one looking line that goes down, and it has that humped shape.
So I'm gonna bring this fish really close to the camera. Go ahead, pause the video here, and you can identify this fish species by using your Clearwater Hudson River Fish Identification key. All right, so if you got Atlantic silverside, you are correct. So this fish is really easily identifiable because they have this nice silver strip running horizontal to its body, giving it its silverside name. In Atlantic silverside, they really need salt in the water. Fish have the ability to expand the range in which they live based on the water conditions of their preference. So during Day in the Life 2020, we found the salt threaded its way pretty far up the estuary, which meant that the salt-loving Atlantic silverside was found at all of these locations. Now, if we compare this to Day in the Life 2018, where the salt did not thread its way as far up the estuary, we only find Atlantic silversides at these locations.
Hi everyone, my name is Marie Roach and I'm here at Croton Point Park today. Croton Point Park is River Mile 35, so we're only 35 miles from New York Harbor. So this fish looks different than you might think fish can look. And what I really would love you to pay attention to is this fish's mouth and body shape, which will help you properly identify. So now would be a great time for you to pause the video so you can try to figure out what type of fish this is. If you guessed a right-eyed flounder, which is a winter flounder, you are correct. We've got some fins up here. We've got these distinct spots, this certain body shape. We've got the caudal fin back here. So now's a great time to pause the video and use your dichotomous key. And if you guessed the type of herring, you are correct.
Hi everyone, I'm Megan. I'm with the Hudson River Estuary program. We're here today, October 22nd. It is Day in the Life of the Hudson River and Harbor. We're here at Peekskill Landing Park in Peekskill along the Hudson River. We just got finished seining. We caught Atlantic silverside, spot-tail shiners, and striped bass today in our seine.
All right, hello, it's noon on the 22nd of October. I'm gonna go take some samples to get information for the Day in the Life of the Hudson. Let's go do it.
The site that we're at is called Duck Island, and it seems ironic at this point because it's connected to land, but it wasn't always. And so if you look at some of the historic maps of West Point, you'll see that Duck Island was in fact an island at one point. And over time, when they added the railroad, they also added some fill. And so now Duck Island is no longer an island, it's in fact connected to the mainland. The Hudson River is an estuary. It's a freshwater river that meets the ocean, and one of the ways that we see the influence of the ocean is that there are twice daily high tides, twice daily low tides. And so on Day in the Life of the Hudson River, we mark the tides. In fact, when Colonel Kimball was out here at 5 o'clock this morning, the water level was right here. We marked it and put a stake in. And then every 30 minutes afterwards, we put another stake in the ground, marking the line at which the water met the land. And so you can see this series of markers every 30 minutes as the tide was going out this morning.
Good afternoon. My name is Tom Blake. I work for DEC's Hudson River Estuary program. I'm here with Travis Cherry today of the New York State Parks Department, and we are conducting our 18th annual Day in the Life of the River. We're at Cornwall Landing today. Cornwall Landing is 57 miles north of the Battery. Even more importantly, it's about 68 miles north of the open ocean. So we often get fish here from the sea. And this one here happens to be a saltwater fish, a type of saltwater fish. It's called the bluefish. This is a baby bluefish. This bluefish was born probably back in May, even April. They come into the river as babies, the size of your little finger or even smaller, because of the tremendous amount of food that's in the Hudson River.
Hi, I'm Mary Lynn Malone, and I'm with the Orange County Water Authority, and we are at Cowie's Unique Area. It's also called Pump Point. It is one of the county parks for Orange County, and we're going to be doing some cool stuff for a day in the life of the Hudson River. Now, to do the water temperature, you need to kind of go out because there are going to be factors that affect the temperature of the water. So think about that. Why wouldn't we want to get water temperature close to the surface? So one of those factors could be that, of course, the sun is shining on the water. The surface is going to be warmer than deeper. So I'm going to take this, I'm going to put it, I'm going to take this, I'm going to put it into the water. We're going to hold it there for about a minute. All right, so we're taking our thermometer out after a good minute, and it's looking like we do have a change, right? Of course, that's going to change rapidly in the air, but we've got our Fahrenheit on this side again, our Celsius on that. Okay, our temperature looks to be about 61. It's actually between those two lines, and let's see, that's 15, maybe 16 degrees Celsius.
This is Kate Phipps here with Scenic Hudson. We're joining you today from People's Waterfront in Newburgh, and we're going to show you a little bit of the site first. We've got a beautiful morning here on the Hudson River overlooking Mount Beacon and the Hudson Highlands across the way. All right, now we're going to be measuring dissolved oxygen. And dissolved oxygen is a measure of just that. It's the amount of oxygen that you can find in the water. And just like we need oxygen from the air to breathe, the fish and other animals that live in the water need oxygen to breathe. So oxygen can be an indicator of the health of the water. We're going to pour this in right up to the top there. And then we're going to transfer it to this bottle. Okay, once that's all in there. Now this is the kind of final reagent. This is sodium thiosulfate standard. And so what we're going to do with this is one of my favorite parts because 1 drop equals 1 part per million or 1 milligram per liter for dissolved oxygen. So let's take a look at this against this white background. You can see that it's yellow, so it's kind of a dark yellow color. We're going to put drops in until that goes completely clear. So we want that to go completely clear. So we're going to go 1 drop at a time. I usually practice beforehand to make sure I'm getting it directly in and not on the sides. So we're going to go 1 drop. Stir it around. Still yellow. Gonna go 11. Ooh, I'd say that looks pretty darn clear.
Yeah.
Yes. So we had 11 drops, which is 11 parts per million.
Thank you so much for joining us for Day in the Life of the Hudson River and Harbor 2020, focusing on the mid to lower Hudson section. Now we are going to take a deeper dive into 2 parameters that we talked about today, so if you want to join me for this exploration, stay tuned. The first one we're going to talk about is turbidity. So turbidity is the cloudiness or the haziness of the water. And if you can look behind me, the Hudson is naturally a turbid system. We typically have a chocolatey brown or even pea soup green colored water, and that is completely normal. It's because the Hudson is naturally a very productive system. It does not mean by any means that the Hudson is dirty. But there are a couple of reasons for why we have such high turbidity in this estuary. One is because we have a high sediment load. So we have sediments or dirt at the bottom of the river that can get picked up into the water column by our moving tides and currents. And because we have this mix of fresh and salty water, fresh being less dense than salty water, it can cause turbulent mixing that also picks up sediments from the bottom of the Hudson and stirs it up into the water column. Now, the Hudson's not known for being a plankton-rich river, but we do have both zooplankton, which is an animal plankton, and phytoplankton, which is a plant plankton, typically peaking in the spring and summer months, and that also contributes toward our turbidity. And the last and arguably most important factor of turbidity is the fact that we are a nutrient-rich river. We have detritus, which is decomposing plant matter that is causing turbidity and providing a lot of nutrients for the animals that live here. The second parameter we're going to be talking about are fish. So, because the Hudson River Estuary has a mix of fresh, brackish, and salty water, we have a huge diversity of species that can be found here. Actually, over 230 species have been found, and we're finding new fish species all the time. And because the estuary is so dynamic and the water conditions are changing all the time, it's really important to look at the fish's preference range versus tolerance range. The preference ranges are an optimal range that a fish wants to live in to thrive. However, there's a wider tolerance range that a fish can endure and survive in if need be, but it's not their preferred water conditions. There's an important distinction between these two words because often during day in the life, we're surprised to find a species that's outside its optimal and expected preference range. But this data is so important because it helps us to better understand how wide the tolerance ranges can be for some of these species. And there's actually a relationship between these two parameters, between turbidity and fish. One of the main drivers for turbidity are nutrients. And nutrients can provide a food source for all these different fish that live in the Hudson River Estuary. And because turbidity is that cloudiness of the water, it can actually help camouflage some of these species from getting gobbled up by predators.
Hey everyone, thank you so much for participating in a day in the life of the Hudson and Harbor. Remember, there's 3 videos that cover the entire estuary from New York Harbor, upriver all the way to Albany, Troy, and beyond. We hope you enjoy them all. Keep exploring, and thank you for being part of a day in the life of the Hudson and Harbor.